We are finishing up Chapter 3. We are in Section 4. I'm about midway down on page 176, and you see the words Exploratory Data Analysis. And I want us to go back to 117 and read the objectives where we started a few days ago. And here are the objectives for Chapter 3. The outline is that we would talk about measures of central tendency. This is a great time to think through your mind, or look through your flashcards, your glossary, whatever you've done, or thumb through the book and go back and remember what were the measures of central tendency. We also went through a section about measures of variation. What were those formulas? What pieces fell into that section? And we just are finishing up 3.3, the measures of position, but we keep going with this measures of position to exploratory data analysis. So with that in mind, I do want to read a couple of paragraphs. And again, what I don't read, you definitely go back and read all of it. But looking here, it says, in traditional statistics, data are organized by using a frequency distribution. Traditional statistics. Underline it, highlight it. From this distribution, various graphs such as the histogram, sound familiar? Frequency, polygon, and ogive can be constructed to determine the shape or nature of the distribution. In addition, various statistics such as the mean and standard deviation can be computed to summarize the data. The purpose of traditional analysis is to confirm various conjectures about the nature of the data. That would be a great something to put on a card, underline, highlight, think on deeply. For example, from a carefully designed study, a researcher might want to know if the proportion of Americans who are exercising today has increased from 10 years ago. This study would contain various assumptions about the population, various definitions such as the definition of exercise, and so on. And here we transition. In exploratory data analysis, EDA, data can be organized using a stem and leaf plot. That's Chapter 2. The measure of central tendency used in EDA is called the median. The measure of variation used in EDA is called the interquartile range. In EDA, the data are represented graphically using a box plot, sometimes called the box and whisker. That was from our last section. The purpose of exploring the data, such as the purpose of, where am I? I'm reading sideways. The purpose of exploratory data analysis is to examine data to find out what information can be discovered about the data, such as the center and the spread. Exploratory data analysis was developed by John Tukey and presented in his book, Exploratory Data Analysis. You're going to go on and talk about some information that we have seen back in 3-3. In fact, you've already looked at that. I'm just doing a summary, kind of closing up Chapter 3, Section 4. That I wanted to mention, go back and look at page 117. I wanted to look at the paragraphs here, and then I wanted to go over to page 179, and I wanted to look at the bottom of that page. There is a table. Again, just kind of putting a lot of this information together for the whole chapter. Traditional versus EDA. We were just reading about traditional, and then maybe reading for the first time about EDA. Here are pieces for traditional. Here are pieces for EDA. Traditional, frequency distribution, histogram, mean, and standard deviation. Those should all be very familiar, and lots of cards made on them, and lots of information on your formula card. Exploratory data analysis, stem and leaf, box plot, median, and interquartile range. And this concludes our Chapter 3.